Now let's talk about multidimensional databases, which represent a special approach to data organizations that's particularly valuable for analytical applications and business intelligence. The key characteristic of multidimensional databases is that they're denormalized, meaning they intentionally include data redundancy in exchange for improved query performance. This is the opposite of operational databases, which are normalized to eliminate redundancy. These databases are designed to handle non-operational, archived, or historical data rather than day-to-day transaction processing. In risk management, this might include historical market data, past loan performance records, or archived customer behavior patterns that are used for analytical purposes rather than operational decision-making. The multidimensional aspect refers to the way data is organized around business dimensions like time, geography, product categories, or customer segments. For example, loan performance data might be organized by time period or geographic region or product type and customer segment. This dimensional organization makes it easy to perform analytical operations like drilling down, rolling up, and slicing and dicing along different dimensions. Multidimensional databases are particularly important for online analytical processing of applications, where users need to interactively explore data from different perspectives to identify trends, patterns, and insights that inform strategic decisions. For AI applications in risk management, multidimensional databases provide the structured historical data needed to train models and the analytical flexibility needed to validate models' performance across different dimensions of the business. Now, let's explore the important difference between OLTP and OLAP systems, as this affects how we design and use databases for different purposes in risk management and AI applications. OLTP systems, which stands for Online Transaction Processing Systems, are designed to handle large volumes of transactional data involving multiple users simultaneously. These systems excel at processing individual transactions quickly and reliably. Online transaction processing typically involves inserting, updating, and deleting data in real time to collect, manage, and secure individual transactions. In a banking context, this might include processing ATM withdrawals, credit card transactions, loan payments, or account transfers. The key characteristics are high speed, high reliability, and the ability to handle many concurrent users. OLAP systems, which stands for Online Analytic Processing Systems, serve a completely different purpose. These systems are designed to process large amounts of data quickly for analytical purposes, allowing users to analyze multiple data dimensions simultaneously. In an OLAP system, teams use data for decision-making and problem-solving rather than day-to-day transaction processing. Instead of processing individual transactions, OLAP systems answer questions like, what was our default rate by region and product type over the past 5 years? Or how do customer risk profiles correlate with economic indicators? The distinction is crucial for AI and risk management applications. You might use OLTP systems to capture real-time transaction data and detect fraud as it happens, while using OLAP systems to analyze historical patterns and train predictive models. Many organizations will use both types of systems in complementary ways. OLTP systems handle operational needs, while OLAP systems support strategic analysis and AI model development. As the data then flows from OLTP systems into data warehouses that support OLAP analysis. Now let's transition from data storage to understanding variables, the fundamental building blocks of data analysis and AI modeling. A variable is simply a characteristic, trait, or attribute of a person or things that can be classified or measured. The example shown here illustrates the diversity of variables we might encounter in risk management. Attitude represents psychological characteristics that might influence financial behavior. Gender is demographic characteristics, could be relevant for some type of analysis. Heart rate is a physiological measurement, and hair color is a physical characteristic. In the risk management context, our variables might include credit scores, employment status, annual income, or payment history. The key insight is that a variable represents the condition or characteristic which in a given study may have more than one value. This variability is what makes analysis possible and meaningful. If every customer had the same credit score wouldn't be a useful variable for risk assessment. Variables are the foundations of all statistical analysis and machine learning. When we build AI models for risk management, we're essentially trying to understand how different variables relate to each other and how they can help us predict outcomes of interest, such as loan default or fraudulent transactions. Understanding variables and their properties is crucial because different types of variables require different analytical approaches and can be used in different ways within AI algorithms. So what is a variable? So this diagram helps us visualize the concept of variables by showing how they connect different aspects of entities we want to analyze. Variables serve as a bridge between abstract concepts and measurable characteristics. The central concept of variable is connected to several ideas: event, act, characteristic, and trait. This illustrates that variable can capture different types of information about the subject we're studying. An event might be something that happens to or is done by our subject, like making a payment, applying for a loan, or experiencing a job change. These events can become variables in our analysis when we measure their frequency, timing, or characteristics. An act represents deliberate actions taken by our subjects, like choosing to pay early, requesting a credit limit increase, or closing an account. These behavioral variables often provide valuable insights into risk profiles. Characteristics are inherent properties of our subjects, like age, income level, geographic location. These tend to be relatively stable attributes that provide context for understanding behavior. And finally, traits represent more fundamental qualities that might influence behavior, like risk tolerance, financial sophistication, or reliability patterns that emerge from historical data. In risk management and AI applications, we typically work with many variables simultaneously, trying to understand how they interact and combine to influence outcomes. This multidimensional view of variables helps us build more comprehensive and accurate predictive models. The interconnected nature shown in this diagram also reminds us that the variables don't exist in isolation. They're part of complex systems where changes in one variable can influence others.